We're going to do log equations, but your log equations are going to involve using all the properties that you guys just learned. And it's also going to use like what we did yesterday, like going from log form to exponential form. So you guys have to be comfortable going from log form to exponential, which we've had enough practice with that. I think you guys are okay there. But when you take a look at these first two problems, the way these problems are set up it's like a good indicator as far as like what type of equation it is and what you're going to do. When you have a log on one side and it just equals a constant, all we know how to do is to write this in exponential form. So which one of those three terms is my base? The base. So the base of 4, right? This is the b. The one that goes under is the base. So here's our base. Which one's the exponent? The 2 over here. And then we set that equal to 2x. Yeah, so we're going from log form to exponential form. That's what we do on the first step. And now it's just a matter of solving that equation. So what is 4 squared? 16. And then we just divide by 2, right? So x equals 8. Okay, then same thing right here. You've got one single log over here, and it's just set equal to a constant. So again, which one is our base?
9.
The 9. And then the exponent, the 2, equals 4x plus 1. So in our first step, we wrote the log form, and we turned it into exponential form. Okay, so what is 9 squared? 81. And then to solve that two-step equation, we're just going to subtract and divide, right? Yeah, we subtract 1 and get 80, and then divide by 4. X equals 20. Okay, so when you guys have log equations that just involve one log and then it equals a constant, those are about the easiest ones you can do. You're just going to turn it straight into exponential form, and then you just solve the equation. Okay? Do you guys feel okay with those? Okay, if you take a look at the two at the bottom, notice how one side has multiple logs and then it's set equal to a constant. This is very similar to what we did up here, except I need to condense this to one single log. Once I condense this to one log, then I can turn it into exponential form like we were doing on the previous two problems. Okay, so right here, let's condense this side. So this is where you guys have to use those properties that we just learned. Log base of 10. Now what would I do with the x and the 8? Multiply them, so wouldn't that be 8x? The right side, you're just going to keep the 1. So log base 10 of 8x equals 1. So now doesn't this look like a problem we just did above? So we condensed first. We condensed, and now we're going to go from log form to exponential form. Okay, so what's our base again? 10 is our base. Exponent, 1 equals 8x. Okay? What's 10 to the first? 10 to the first is 10. And then we'll just divide by 8. So here's one of those problems where if you leave it as a fraction like I do, 10 over 8 has to reduce. So you could not leave it as 10 eighths. Yeah, so I left my answer as 5/4. But if you guys had taken 10 and divided by 8 and wrote it as a decimal, it would be 1.25, and that's fine too. Okay, good? All right, then this one. Here we have two logs. They have the same base, which means we can combine them. We can condense them to one log. And then it's set equal to just a number. So we're going to do the same process we've been doing. First condense. So we have log base 2 of, now let's talk about what this is going to turn into. What am I going to do with the 8 and the 3x minus 2 since there's a minus sign between them? Yep, it's going to be a division problem. So the 8 goes on top, 3x minus 2 goes on the bottom. Now we do nothing with the right side yet, so you just put equals -4. Okay, so now we can turn this to exponential form. What is our base? 2. What's the exponent? -4 equals 8 over 3x minus 2. Yep. Now remember yesterday we talked about those negative exponents? Remember negative exponents just means reciprocal? So look, this right here is the same thing as 1 over 2 to the 4th. Negative exponents just move like it just flips it. Okay? The reason I wrote it like that is because if the right side is already a fraction, wouldn't it just be easier for the left side to be a fraction? Because then we can just do a proportion. We can cross multiply. So you guys might want to look up here so you can see what I'm doing. I'm going to take the 1 and I'm going to multiply by the 3x minus 2. Isn't that still going to be 3x minus 2? 3x minus 2. Then equals. And when I go this direction, can you guys type that into the calculator for me? Can you type in 8 times 2 to the 4th? What is it? 128. Okay. And now we just have 2 steps, right? A 2-step equation. We're going to add and divide. Add 2. 3x equals 130. And then divide by 3. So guess what I left my answer as? 130 over 3. Now, if you don't want to leave it as a fraction, if you guys type that in, you'll get a decimal, and it will be a repeating decimal. So I told you guys repeating decimals are fine. What is that? 43.3 repeating? Is that right? No. Look, you guys have me lying. 46. No, I was right the first time. 43.3. Well, because I was hoping one of you guys would have typed it in by now. But nobody's saying anything, so 43.3 repeating. Yeah, I don't know what I was doing. It is your fault. I said type it in. You guys have the calculators, I don't.
Well, you said if you wanted to the fraction to the fraction, I think all of us is like to the fraction.
Okay. Well, it's 43.3 repeating. All right, whenever you guys are ready, turn the page. Huh? I'm not a big fan of how this next one is written, but remember, in order to condense two logs, they have to be on the same side, right? So notice how this one is on the opposite side of this one. Couldn't I just add it to this side? Like, can't I just add the log base 3 of x plus 3 and bring it over? Why, yes, Melissa. Yes, you could. All right, I'm going to go ahead and add the log base 3 of x plus 3 to the left side and the right side, technically. But when I add it to the right side, you guys know it just cancels that out. When I add it to this side, this would be gone. So I'm just moving it over. So all that's left on that side is the 2. Okay, so now, how do we combine these two? How do we condense them? Since it's addition. Yep, so log base 3 of x minus 5 times x plus 3 equals 2. How are we going to multiply a 2 by 2? What do we use? We use a box. Good job. So we are going to take, this is side work, you guys got to do this somewhere else. We got to multiply x minus 5 times x plus 3. Because that is going to become the left side of our equation. X times x is x squared. X times negative 5 is negative 5x. 3 times x is 3x, and 3 times negative 5 is negative 15. So what's that all going to give me? X squared minus 2x minus 15. So now that I condensed the left side, can't we now turn this into exponential form? Yep, we sure can. My base is 3. My exponent is 2. And I set it equal to the quadratic x squared minus 2x minus 15. So now what is 3 squared? Nine? Yeah? I'm going to make this a 9. And how would I move that 9 over so that way this side can be a 0? Add it or subtract it? Subtract it. Yep. Yeah, you get to do your favorite thing. You get to factor. I know. You got all kinds of space. So we have a negative 2 on the bottom and a negative 24 up top for our asterisk. So I just went over here to do it because I, room. What two numbers? There. What two numbers multiply to give us negative 24 but add to give us negative 2? See, 2, 12, 3, 8, 4, 6. Okay. And the 6, the bigger number, has to match the bottom. So it's negative 6, positive 4. So those are our two sets of parentheses. Those are not our two answers. Those are our two sets of parentheses. X equals negative 4. Oh, can't really see that. X equals negative 4 and X equals 6. Okay, so right now we have two possible answers. What I would like for you guys to do is one thing that you guys need to understand. You all have your calculators, right? Pick them up, hit the log button, and then type in the number 0. What does it say? Domain error. Okay, type in log and then pick any negative number you want. It's probably going to say domain error again. Okay, so this is what you guys need to know. Whatever is in parentheses, so like this right here, the x minus 5 and the x plus 3, those can never equal 0. So like, look, if I had gotten an answer of x equals 5, I'd have to cross it out, because that would make 5 minus 5 would be 0. And you guys just told me that you can't have a 0, right? We also can't have negatives. So if I had a positive 5 or a negative 3, I'd have to cross them out, because that would make both of those 0. However, we also can't have a negative in here. So if I plug in negative 4 to either one, wouldn't they both be negative numbers? Like negative 4 minus 5 is negative 9, and we just said you can't have a negative inside there. Negative 4 plus 3 is negative 1. So that negative 4 is extraneous. Now if you plug in the number 6, 6 minus 5 is 1, 6 plus 3 is 9. Both of those numbers are positive, so that's fine. So you guys do have to be on the lookout for those as well. Huh? Yep, that one's done. That one's a lot of work, I know. That one's a lot of work, I know, I know.
As always. I seem to be chaotic, so sorry. We're not only as good as 99% of
All right, down here at the bottom. Now look, these are going to switch, because now notice how there's a log on each side. See that? Okay, do you guys remember yesterday when we did those exponential equations, once their bases were the same, did we have to use the base anymore? No, we just had to say this equals this. This is the same concept. If you have a log over here that's a base 10 set equal to another log base 10, doesn't that mean that this has to equal this? Even though they look different, wouldn't they have to be equal to each other? They'd have to. So essentially, you don't even need, like if you have one log per side only, you get to ignore the log part of it, and you get to just set the two expressions equal. These are the simplest kind. So how would I solve this? Subtract 5x. So you get 2x equals 10. And then divide by 2. So x equals 5. Okay, cool. This one over here, you've got 1 log per side only, which means this expression has to be equal to this one, otherwise there wouldn't be an equal sign between them. Okay, so we get to ignore the word log, and we're just setting 4x minus 1 equal to 2x plus 3. All right, what would you guys do first? So we're subtracting 2x, and then add 1 to give us 4, and divide by 2. So x equals 2. Now I want you to understand, like I really have been, once I get my answer, like this 5 here, if I had plugged it in here, that'd be a 35, this would be a 35, we're good. If I plugged in a 2, that would make that a 7, that would make that a 7, so they're positive numbers, which means this answer is fine. The only time this answer would be extraneous is if you plug it in and they either come out to be 0 or some negative number. We've just got 2 problems left that are on the next page, and then I'm going to go through and talk to you about the practice page. Okay. I would like to go to this one real quick. I'm saving this one for last. Okay, so if you look here, 1 log, right? 1 log per side. So how do I start this problem? 16 plus 2b equals, yep. And since we have a b squared, that's a quadratic, isn't it? So don't I have to bring these 2 terms over? Subtract 2b and subtract 16 from both sides of the equation because we need one side to say 0. These 2 will combine to make a negative 6b, and then the minus 16 just goes at the end. Now what do I have to do? Yep. We're going to figure out negative 16 and negative 6. Positive 2 and negative what? 2 times what is 16? 8. Negative 8. So negative 8 plus 2 would be negative 6, and negative 8 times 2 is negative 16. So we've got one set of parentheses that says b minus 8, and the other one says b plus 2. So we could just go ahead and go to our 2 answers. What are my 2 answers going to be? Now let's... Well, no. The number here can be negative. What can't be negative is if you plug it in and it leaves it negative. So if I plug in a negative 2 right here, 2 times negative 2 is negative 4, but then plus 16 stays 12. So that would still be a positive number, so that's okay. And the 8 would most definitely give you a positive number. So actually, both of these answers are fine. Now the difference between number 2 and number 2 only had 1 log per side. What do you notice on number 1? Don't you have 2 logs over here? And when there's 2 of them, don't we have to condense it to 1? Okay, so let's condense this. We're not going to do anything with the right side because the right side is just 1 single log anyway. But how do I condense those? Not plus. Yeah, the 7 and the x get multiplied together, right? Because it's addition. And when we condense it, we turn it into multiplication. So I just wrote 7x. Now, yes, it is a base 10. But remember, once you just have 1 log per side, don't we just ignore the word log in the base anyway? So this and this get ignored, and we simply have 7x equals 37. Now let me tell you, can you guys type in 37 divided by 7 on your calculator? Yeah, but I want you to see the decimal. The decimal does not end and it doesn't repeat. So I don't want you to write it as a decimal. I want it left as 37 sevenths. I told you guys the other day, decimals are fine as long as they end or they repeat. If it is a decimal that goes on for, forever in the calculator and there's no repeating, leave it as the fraction. Okay, that is the end of that lesson.